Today we're going to talk about the factory AC. So my car is a factory AC car, and for a 1970 Nova, some things you'll notice about a factory AC car: it has this set of center vents, which don't come on the normal Nova. It also has AC specific controls here on the control unit, and of course the big air conditioning box underneath the hood. Before we talk about how all that system works, I want to talk about how it is supposed to be controlled, because after all, air conditioning is all about keeping you comfortable in the cab. So we're going to start with this control unit, and I'll explain how it functions. Alright, so starting at the control panel, there's a selector switch at the top for the fan. It has 4 positions and off. So you got off, 1, 2, 3, 4. Those are for different fan speeds. You also have a leftmost lever. This one operates 3 functions. One is it operates the switch that allows the AC compressor to turn on. It also operates a vacuum valve that will open and close ducts in order to make air recirculate or not recirculate at the right time, or shut off the heater valve. And it also operates the blend doors that allow air to direct either through the air conditioning evaporator or through the heater core, or both in a sort of a blend mode. So when this switch is in the very topmost position, the ducting is on outside air, it's on vent. The air conditioning compressor clutch is not going to be engaged, and if you turn on the fan, you're just going to be blowing outside air into the car in a recirculation mode, in an outside air mode. When you move this switch down, or this lever down to the max position, there is a switch that is going to provide power to the AC clutch, which will start operating the air conditioning system. On this factory AC system, the compressor runs continuously. Anytime this lever is here or below, with one exception we'll talk about in a minute, but the AC compressor is going to be running, and when it's in the max position, there's also a vacuum valve that's going to close a flap on the cowl and open a flap inside the car so that air will recirculate, and you'll be getting the most effective cooling because you're cooling the inside air repeatedly in the car. It will also shut off the vacuum valve that supplies the heater core, so engine coolant will not run through the heater core when it's in the max position, giving you the most effective air conditioning possible in that position. Once you move this lever down to normal or below, you're essentially blending between the air conditioning and the heater, and so some air is going to pass through the evaporator to be cooled by the air conditioning, and then it's going to continue on to pass through the heater core to be reheated. So it's a reheating system. If it's on norm, it's mostly going to be passing through the air conditioning evaporator, and as you move this lever down, more and more of the air is going to pass through the heater core until you get all the way to the bottom, in which case almost all the air is going through the heater core. So you can think of this as sort of your blend lever. A lot of 1980s cars would have sort of a blue turning into red to show that it's going from cold to hot. It's kind of how this one works as well, except the AC unit is always running when you're in these positions. The other thing that you need to know is that from norm and below, the vacuum valve is no longer providing recirculated air, and it's going to be set up to provide outside air, and it's not going to shut off the heater core. So anywhere down below norm, you're going to get a little bit of heating going on, and you're going to be on outside air. So air is coming fresh from the outside into the car. That's how that leftmost lever works. Now the middle lever, you'll see at the top it says AC, and then it has bi-level from here to here, and then down here it says heater. So this lever operates a cable that's opening and closing a big flap that allows air to be directed toward the floor of the car. So if you have it up here, the air is going to be going through the vents in the dash. It's going to go through the center vent and the 2 left and right vents, and as you move it down here toward bi-level, you're going to be getting some blending. Some air is going to come through the dash, some air is going to come from the floor. When you get it all the way down to the very bottommost position, heater, now you're going to get all the air coming from the floor. And something else that happens is there's a switch on the box that will now shut off the air conditioning compressor. So if you have these two levers all the way in the down position, you have this one providing the flap so that air is going mostly through the heater core or all through the heater core, not the evaporator. Then you have this one that's directing air toward the floor and operates a switch to shut off the AC compressor. This is your maximum heating position. So this is going to get the car the warmest the fastest if you put it in this position. The last lever here is for the defogger. If you have this in the upmost position, there is a flap that is near the ducting for the heater at the floor that will allow air to continue going to the floor. As you move it down, it is going to direct that air from the floor up to the vents on top of the dash, and it's going to bleed a little bit of air to the vents that are in the that are coming forward at you from the instrument panel, so that a little bit of air will go to the side windows. But most of the air is going to be directed through the defrosting ducts that are on top of the dash up near the windshield. This position is going to direct hot air with no air conditioning on, hot air through the defroster ducts at the top. But if you want to improve the defogging, sometimes you can put this center level up closer to bi-level, and the AC compressor will operate, and you'll get a little bit of dehumidifying effect from the AC compressor, which may help to de-ice the window depending on the conditions that you're in. So if you're trying to defog your window, you might try a position like what I'm showing right now, which will direct some air down toward the floor through this defroster duct up to the windshield, and also operate the AC compressor so that it'll do a little bit of dehumidifying. Alright, so most of the time when I'm in the car, I have this defroster off. I have it in the AC position during the summertime, and then I will operate either at vent or in the max position, which means either I'm getting outside ventilated air or I'm getting air conditioned air, and then I will select a fan speed that makes sense. Usually I'll have it on high, and that'll blow quite a bit of air through all of the vents. I will talk a little bit about the vents themselves, so you can kind of see some other options you have for directing the air. Alright, let's talk about these center vents first. In the 1969 through 74 Nova, the center vent is shared with the 69 Camaro. You can actually get a reproduction unit of this, and this is a reproduction unit because my old one, all of these little doors were broken. So you can direct the air using these doors. You can rotate it up and down. You can even somewhat shut it off if you close these things down. And that's how I direct the air. If I'm the only one in the car, I'll have both of these facing toward me. This lever on the right will, in the bottom position, is completely open. It's allowing air to mostly come through the center vent. If you move it to the up position, it closes off this vent, and more of the air will come from the left and right vents. So usually I have it just completely open. So speaking of the left and right vents, now these are the original vents. They can turn left and right and up and down. One of the things that I didn't know about on this car when I first put it together is that there is a lever here with a cable that will open and close just that vent. So if it's forward toward you, air will come through the vent, and if you push it all the way forward, it'll close it off, and that vent will no longer provide air. So if you want to if you just want air going to yourself, you can come around on the passenger side, and it has a similar lever down there, and you can see I've got that one closed off. So if I don't have a passenger in the car, I'll usually have that vent closed, so all the air is directed through the center vent and the vent on the far left. So let's take a look here under the dash. I'm looking below the glove box on the passenger side. Over here is where the air will exit if you have that center lever all the way in the down heater position, not in the bi-level or AC position. So air will come out of here, and there's also usually another one of these down here. I have it duct taped off because I'm missing the vent. If you want to heat the car, that's usually where the air will come out. This is part of the box that houses the ductwork and the control levers for going through the heater core. And on the right side of an AC car, you'll find this big hump of plastic, and that's covering a vacuum operated flap that allows air to be drawn through the blower for recirculation mode. So as far as I know, only the AC cars have that recirculation function, and that's for getting the maximum air conditioning performance. Alright, so I've got the car running now, and I've got the fan on its highest speed. You can see if I select the lower speed, you might be able to hear it's really quiet. And I have it operating just on vent, which means we're getting outside air coming from the cowl through the duct. Right now, the temperature is about 80-82 degrees coming out of the vent. And we'll go ahead and just try turning on the air conditioning to max. Alright, you might have heard the idle go down a little bit because the compressor turned on. And now we're going to watch as that gauge starts to come down a little bit as the air conditioning begins to do its job. Alright, so remember we were at 80, a little over 80 degrees, and it's starting to come down. We're just idling in the shade. So as you go down the road, you'll get cooler vent temperatures. But for right now, we'll just go ahead and watch it come down. It only takes 30 seconds or a minute to reach a nice cool temperature. So this is factory air conditioning. I've updated it to R134, and there are a bunch of changes that need to be made to make that work well, which I'll explain in another part of this video. But you can see it's starting to come down. We're getting near about 50 degrees. And usually this system, especially just sitting in the shade at idle, it'll come down to right above 40 degrees or so. When you start going down the road, it'll get even cooler. And if it's running properly on recirculation, you'll get the best performance. So right now we're just slowly coming down, and we'll see it eventually reach around 40 degrees. Well, unfortunately you can't see it, but under here there is a flap that's open that's allowing air to come from the inside of the cabin into the blower motor and get recirculated back up here to these vents in the dash. Alright, I've been driving down the road. You can see the vent temperatures come down to about 45 degrees or so. When you're moving, you get more air going through the condenser, and that helps achieve cooler temperatures. Plus it takes some time to cool the air off inside of the car. More than comfortable in here. Look at that, going down the road, we are darn near 40 degrees on high fan speed. The system's working great, very cool inside the car. Alright, so we talked about how the AC system functions from the inside of the car. You get to see the performance. It works fantastic in this car. I'm really happy with it. It keeps me cool. Let's talk about what's under the hood and how this thing operates. Alright, let's take a look under the hood. Aha! Factory AC, but this is definitely not a factory engine. How is that possible? We'll talk about that a little bit. Alright, air conditioning. The main unit that you will see under the hood is mounted to the firewall, and that's this big evaporator box, also sometimes referred to as the suitcase. And a lot of people want to get rid of this because it's ugly. Look at that thing, really distracting over there in the engine bay. You could have had a lot of room over there, so why keep this big ugly factory unit? Well, the main reason is it has an enormous evaporator inside, which has a huge capacity for cooling the car. Alright, so what's inside of there? Well, there's a large evaporator. It's a heat exchanger. It's just made out of aluminum. It's got a bunch of fins, and air flows through it. And if you imagine that evaporator is right here, air is flowing through it and along this route back into the car. The blower is located behind the fender. I can't really show you where that's at, but it fills air on this side of the box, pushes it through that evaporator where it's cooled off, and then it goes through this ductwork into the cabin. Alright, so the whole purpose of all the bits and pieces I'm going to show you from here on out are to make sure that the air coming through this evaporator, make sure that air can get cooled down as much as possible. Now, if you look very carefully, right here underneath the cowl, you will see this big vacuum operated diaphragm, and that is the unit that's going to allow air to either come in through the cowl for fresh outside air, or it's going to close it off so you can get air from inside the car to recirculate. So there are a few major components underneath the hood for the AC system. One we already talked about was the evaporator that's over there. There's also mounted near the evaporator is this guy. This is the thermal expansion valve. We'll talk about what that does. There's also the compressor. Now my air conditioning compressor is mounted way down here underneath the engine down by the frame. I've notched the frame out to give it some room. That's the compressor. There's also a dryer receiver, and that's right here. There's a little sight glass in here. You can actually watch the R134a refrigerant pass through here. And then up front is this unit, which is the condenser. And the condenser looks like a radiator. It goes all the way across the front. You want as much air flowing through there as you can possibly get. Alright, so let's talk about how the system works. Alright, the heart of the air conditioning system is the evaporator. And it's named because refrigerant inside, the R134a, is evaporating. Alright, it starts out as a liquid. It enters as a high pressure liquid right here, and it comes into this expansion valve. And that's called an expansion valve because the refrigerant, when it comes through, wants to expand. So it has a high pressure coming in, there's a very small orifice, and it comes out at a very low pressure. The pressure is so low that liquid refrigerant wants to boil. If you've ever tried to boil water at an elevation, you'll notice that at elevation where there's a lower pressure outside, it'll actually boil at a lower temperature. And if you try to boil water down at sea level, it takes a higher temperature. Well, something similar happens with refrigerant. When the pressure inside of that evaporator is very low compared to the high pressure that it's actually at when it comes in, the refrigerant wants to drop temperature very, very low and start to boil, and that's exactly what happens. It comes in here as a liquid, goes into the bottom of the evaporator, and as that liquid passes up through the evaporator, hot air from your blower provides energy to boil off that refrigerant. So the refrigerant will come, as it comes through here, it'll boil and it'll eventually become a gas before it exits the evaporator through this tubing here. So as you're driving down the road, there's this constant percolation of the refrigerant inside of here coming out at a low pressure, dropping temperature very, very low, and then boiling from liquid to a gas or evaporating as it comes out of the evaporator. Now I promise you I'm going to come back to this unit here later and explain what it is and what it's for. It's called a POA valve, but we're not going to talk about that just yet. Let's just talk about this now heated refrigerant that's a gas. It's going to come out of here and go through this line, and it's a gas down to the compressor. The compressor is going to raise the pressure up very high, so it is a high temperature, high pressure gas coming out of the compressor. And what's really hard to see down here is there is an exit line coming off of the compressor, and that's going up front now to the condenser. Alright, so we have a high pressure, high temperature gas coming through this line from the compressor and going into the condenser. And the condenser, like the evaporator, it has an apt name. It condenses the refrigerant. So it comes in here at a high temperature as a gas, and as it flows through all these channels with these wrapped around pieces of fin, air coming through the front of the vehicle, pulled through by the engine fan or ram air as you're just driving, will act to take heat out of that high temperature, high pressure refrigerant, and it is going to actually condense because it's at a high enough pressure now that it wants to condense pretty easily. And so as it goes through here, it'll cool down and become a liquid. And by the time it gets done being cooled by the condenser, it's going to exit at the bottom. Right? You can see the exit fitting coming out right here. It's going to exit as a high pressure liquid. Now I can't show you all the lines because they're kind of hidden inside of the car, but that high pressure liquid is going to come from the condenser into this guy. This is a dryer receiver. So what happens is inside of here, This will absorb any moisture that might be left in the Freon when you charge the system, and it's also going to provide a little extra volume in case there's any little bits of if you need a little storage for liquid refrigerant for the system. So that high pressure refrigerant is going to exit the dryer, and it's going to head over here back to where we started. It is now a high pressure cooled down liquid that can now go through that expansion valve, drop in temperature, get boiled in the evaporator, loop back through, get raised in pressure in the condenser or in the compressor, come back to the condenser to condense and get cooled off, and the system just keeps operating in a loop. And that's how you get the heat from out of the air going to your cab and out here to where your condenser is into the air in the environment. So we went over all the basic parts of the air conditioning system, and those are common to just about any car or any mechanical refrigeration system. What we didn't talk about yet is this guy, the POA valve. The POA valve is a pilot operated absolute valve. All right, the pilot operated means it's actually open and closed by the pressures of the fluids inside of it, and the absolute means that it's trying to control an absolute pressure. So this vehicle runs the condenser or the compressor all the time when the air conditioning is demanded is on. And if it were to just run all the time uncontrolled, the temperature inside of this evaporator would get so cold that it would actually freeze the water in the air going through it, and that would ice up the evaporator, which would prevent air from blowing through, and the AC wouldn't work at all. The way engineers resolved this issue in the 1960s and 70s on these systems is they made sure that the boiling point of the refrigerant inside of the evaporator was always kept at a temperature right about or above freezing. And the way they did that was by controlling the pressure inside of the evaporator using this POA valve. Remember how I told you that when you're at sea level, water wants to boil at a certain temperature, about 100 degrees Celsius or 212 degrees Fahrenheit? Well, that's because there's a certain absolute pressure at sea level that dictates that boiling point. And when you go up a mountain and you try to boil water, it's actually going to boil at a lower temperature. And the reason is there's less pressure up on the mountain at elevation, and so it's easier to boil that fluid. Well, the same thing happens with refrigerant. R134a has a particular boiling point for every pressure that you might have it at, and it's dictated by the absolute pressure. And this POA valve controls that absolute pressure so that when the refrigerant comes through the expansion valve and goes to a low pressure, that pressure set point is designed to keep the refrigerant boiling at just about 0 degrees. That's the job of this valve. After this valve, the compressor can suck it down to whatever pressure it wants, maybe something well below, and the temperature may get very, very cold, even colder than 0 degrees past the POA valve. You might see frost forming on the POA valve because of that, but at least the temperature inside the evaporator will be kept at 0 degrees or greater so that it doesn't ice up and you can get the maximum air conditioning performance from the system. Now, before I go any further, let's talk about a couple other elements of the system that you can find under the hood. Up here on top of the evaporator box, you'll see a wire connector here going to this sort of flange. Underneath here are a set of resistors that are used to control the blower speed. So when you're selecting the blower speed that you want, it's going to route the power through different combinations of the resistors so that the blower will run at the low and middle and higher speeds. You'll also see here there's a relay, and this relay is one that I had to replace. It wasn't working, it was melted down. But that relay is used on the high blower speed, and it provides full voltage to the blower whenever you select the high blower speed. Another element you'll see under the hood just below the POA valve is this guy. You'll see there's wires coming in and out of it. Those are the wires that go to the compressor clutch. That is an ambient sensor, ambient temperature sensor. If air blowing into the evaporator is below 37 degrees Fahrenheit, it just won't allow the compressor to run, and that is to prevent running the system when you're not going to be able to air conditioning anything at all anyway. So if you live in a really cold part of the country, you'll need to make sure that that switch is hooked up and working properly. Now, on top of the dryer receiver, I also have this switch. This is a high-low switch It's a safety switch that prevents the compressor from activating if the pressure in the system is too low, indicating that we've lost charge, there's not enough Freon in the system, or if the pressure gets too high, indicating something might be clogged in the system and the compressor is just over pressurizing. That'll switch off the compressor clutch and keep it from running. Another important element that you'll see here on my inner fender is a heater bypass valve. Now this is not the original bypass valve to the vehicle. This one came off of a later model vehicle, but these are the coolant lines coming to and from the engine to bring hot coolant to the heater core, and there's a vacuum line here that will shut this valve off so that the coolant will just recirculate back to the engine and won't go to the engine core if you're in the maximum AC position. So let's talk about what you need to do if you want to get a factory AC system working well with R134a. So these systems originally ran with R12 Freon, which turned out to be pretty bad for the environment. So in the late 80s, early 90s, there was a big transition to 134a, which is a new type of refrigerant that is less impactful to the environment. Now remember, I told you that the refrigerant has a boiling point or an evaporation point, also known as a saturation point, that's dictated by the pressure that it is sitting at. So if you have a higher pressure, the boiling point will be higher. You'll have a higher temperature at which it boils, and so it's really important that the pressure inside of the evaporator is optimized for the type of refrigerant you're using. And if you recall, I told you that this valve here, the POA or pilot operated absolute valve, this guy is what regulates the pressure inside of the evaporator in order to prevent it from icing over. And it actually has a set point that's adjusted originally from the factory to optimize the boiling point of R12, or the saturation point of R12. What that means is that R12 in this system will evaporate in that evaporator at about the temperature of freezing for water, and that's totally fine for R12. But if you put R134 in the system, that same pressure that POA valve is trying to regulate in the evaporator is going to result in a higher temperature for R134. That means that evaporator is going to be operating at a higher temperature, several degrees hotter, which means you're not going to get as cold of air going into the cabin. So it's very important that you adjust that POA valve, the pilot operated absolute valve, so that it has the pressure set point that's right for 134a, and that will allow 134a to boil at that temperature that's close to the freezing point of water, which is what you want for the best air conditioning performance. Another part of the system that really needs to be upgraded is the condenser. The original condenser on this system is a tube and fin. This is not. This is what's referred to as a parallel flow condenser. If you looked at the original, you would see a piece of tubing that is snaking back and forth through this entire surface of the condenser and then returning back to the system, and then it has a bunch of fins between it. Unfortunately, that system just doesn't transfer very much heat, so you want to upgrade to this type of condenser, which is a parallel flow shell and tube condenser. Refrigerant is running through these little tiny flat tubes, and then there are fins in between to help transfer the heat, and these transfer a lot more energy as you're going down the road than you can possibly transfer with the original tube and fin style of condenser. And that's important because 134a doesn't have quite the capacity for cooling as R12, and so you really want to maximize the heat transfer performance. Definitely replace the condenser. Don't use an original. There's no point. It just doesn't work as well. I've installed a condenser from Vintage Air. You can get a universal condenser and mount it yourself. You want it to be as big as you can possibly fit in the opening. If I was doing things over, I would probably cut out the core support to the size of the big block radiator core support and use an even larger condenser, but this is still working really well. Another component you're going to want to replace anytime really that you open up the system is you're going to want to replace the dryer. This has a desiccant inside, and that desiccant will absorb all kinds of nasty stuff anytime you open the system. You really don't want that circulating, so you definitely want to replace that. And you're going to have to replace all of the hoses and the O-rings so that they'll seal properly. You need barrier hose that's appropriate for 134A. And usually as you're replacing the hoses, they're going to come with beadlock ends that are crimped on. That you'll have to crimp them on yourself, or you can buy them pre-made. And they'll come with O-rings that fit in this section here for every connector. Those newer style of O-rings are important to keep the system sealed for 134, and you're going to want to replace them all anyway. Another component that absolutely needs to be replaced is the expansion valve. Alright, so this is the thermal expansion valve, and the reason it needs to be replaced is this valve actually regulates how much Freon goes into, or how much refrigerant goes into the evaporator, and it does it based on this sensing bulb. You see this coil of copper? That coil of copper is connected to a sensing bulb that's underneath this insulation, and it's measuring the temperature of the outlet of the evaporator. And that valve is going to close off so that there's not so much refrigerant going through the system that it continues to come out in a liquid form. You want to make sure that you boil all of it off. And it does that by checking the outlet temperature to see that that temperature is a little bit higher than the boiling point of that refrigerant. So if it boils at, say, 0 degrees Celsius, this valve is going to close down to make sure there's always a few degrees higher, which is called superheat. There's always a few degrees higher at the outlet, indicating that it's all gone, become a gas, and it's actually heating above the boiling point, so that you don't send liquid back to your compressor. Compressors do not like liquid. They will just blow up. So you want to make sure that you're only sending gas through there. And if you have an original expansion valve and you put 134A through it, this temperature at the outlet and the way it adjusts in the valve is just not going to be optimized for 134. Not to mention, these valves tend to get clogged and it may not operate very reliably. It's not a very expensive part. You really do need to replace it. The last thing I'll talk about is the compressor itself. Now, the original AC system used the Frigidaire A6. It's a giant cast iron compressor that has a pretty big capacity, around, I think, around 220 cubic inches per rev, which means it's able to move a lot of Freon, and it's able to keep compressing it to higher pressures in order to achieve high temperatures at the condenser, which allows you to get down the road and be cold. That compressor is rock solid, and they can still be used with 134A, but you know, they're 50 years old. In this case, I'm using a Denso 10S17 compressor, which has, I think, around 180 or 190 cubic inches per rev. It is able to keep up with the system and all the conditions I've operated it in, but you do want to make sure you have a good working compressor and that it has a good working clutch on it. The other thing that I would recommend that you do is go ahead and flush the evaporator. That's really, the evaporator and the POA valve are the only components you really need to reuse on this system. Everything else under the hood should be likely replaced: the condenser, the dryer, the compressor, the different hoses. But the evaporator itself is going to get reused. So you can buy an AC flush. It comes in an aerosol. You want to flush it out really well, blow it out with air, get as much of the crap out of there as you can, and also flush the POA valve. And then you'll need to adjust, as I said, you'll need to adjust the POA valve, and I have another video on that which I'll put in the comments. Now, before we wrap it up, let's talk about why you might want a factory air conditioning system versus why you might want to go with an aftermarket system like an Old Air, Vintage Air, that kind of thing. The factory AC has a very large capacity. I showed you earlier that evaporator on the firewall is pretty big. Those under dash units have relatively small evaporators. They can still cool great, but it's not as big as the factory air conditioning. Another reason you might want factory air is that unlike the under dash units, you can get outside fresh air coming from the cowl, which, you know, is maybe a benefit if you got somebody in your passenger seat that made a stinker and you want to roll the windows down and blow some cold air into. That's kind of nice. It's not just recirculation air, which could be a good benefit for you. The third reason is maybe you just want originality. Maybe you're doing a resto mod or a restoration and you want to have the original functionality and get the system working. I love the fact that my car has the original AC system, and I got it to work, which is pretty cool. So why might you want an aftermarket system? Well, you know, this system's 50 years old. All the seals are bad, the cables don't always work right, these levers are pretty hard to use, there's a big ugly box on the firewall, there's a lot of system pieces that you have to piece together and troubleshoot and replace. You can get through all that with one unit that's already built and ready to go with an aftermarket unit. Maybe that's more your speed. And finally, there's this thing. It's big, it's ugly, it takes up a lot of space, there's wires and tubes coming out of it all over the place. Aftermarket AC, you can get a nice smooth firewall and get that out of the way. Alright, I hope you guys appreciated that video on the factory air conditioning on my 1970 Nova. There are a lot of different systems in the 60s and early 70s that operate exactly the same way. If you have any questions, I'm happy to help. Shoot me a message or leave a comment.